So the exam will consist of 3 parts. Mid exam questions consists of 3 parts. Part A, Part B, and Part C. So Part A is around 5 short answer questions. Part B, 6 essays question. This is you may see that there is a different short essay question, and Part C is also 2 essays, but it's a quite long version of Part B. And for Part A, for each question, the maximum grade will be 2. And for Part B, for each question, maximum grade is 3. And Part C, maximum grade is 8. Okay. Okay, so that's the about the structure of the exam question. And then the duration, I haven't obtained the exact information about the time for the exam, but the duration for the exam here is around 120 minutes. So it's 2 hours. It's a 2-hour exam. Okay. Okay. So for Part A, you only need to write the final answer only. For Part B and Part C, you have to write the detail of your answer. I mean, you have to include your argument. How do you find that answer? What is the foundation of this answer? What is the reason and so forth, and then the detail of the calculation. Okay. Okay, so today we'd like to try to do a practice exam to see what is the type of question in Part A, B, and C. Okay. Okay, probably I will prepare for the perhaps the tutorial problem to see the illustration for each question. Okay. As I mentioned before, Part A should be a question about the concept question. So it should be short, and and of course the calculation is short, but you have to know deep understanding about the material. Okay. Okay, I will see. Start with the. Okay, we'll see, or we will browse the possibility of the question type of Part A in the tutorial problem. Okay. So in this case, okay, one of the possibility of the Part A question is should be similar to the concept review. Okay. For example, if you consider this concept review, especially if you, for the topics on a function, especially I recommend you to consider, let's say, the translation of the graph of the function. Let's say like 1G here. Okay, so you have to know if you are given the picture or the graph of the function, then you have to know how to sketch the graph of the function by considering translation horizontally, okay, with respect to the x-axis, or translation vertically. Okay. with respect to y-axis. Okay, so you have to know the difference between these two. Okay, and for this one, okay, so the probably the idea is that, for example, if you are, yeah, the question might be in the type of finding the domain or the range of the function. Okay, so if you are given an elementary function, then you should know how to obtain the domain. Then if you want to consider the translation, okay, with respect to the x-axis, so you have to know how to translate the domain of the function. Okay, yeah, it's a type of number 9 or 10 here. Or if you consider, let's say here, number 19, okay, number 19 here, if you are given the graph of the function like this, okay, for example, this is the graph of the function f. Then if you are given the graph of a function g defined by g of x equals to f evaluated at x minus 2. So the idea is that just to translate the graph of f to units to the right, to units to the positive x-axis. Okay. Okay, so that's the example. Of course, if you replace minus and plus by plus sign there, then you have to translate it to the left, to the negative x-axis. Okay. Okay, so that's the idea. Of course, there is a variation to this problem, namely, let's say if you have the following relation, then let's say the domain of f is restricted to, in this case, -4 until 3 here, then you should solve the equation x minus 2 is in between -4 and 3. And then the x or the domain of g should be in between -2 and 5. Okay. Yeah, so you can view this geometrically or using the algebraic equation. Okay, should be naturally x minus 2 should be lies on the domain of f, and then just solve it for x. Okay, so that's the idea. And then okay, similarly for 19b, okay, if you consider the translation with respect to the y-axis, so just move the graph of f 1 unit above. Okay. Of course, if you replace plus sign here by minus sign, then you have to move, or you have to translate the graph of f 1 unit below. Okay, so that's the idea. Okay, of course, you have to check C, D, E, F, and as well. Okay? And actually, yeah, although we can see this as the translation or dilation of function, you may also view this as the problem about the composite function. I mean, the composition of the function. Okay. Okay, so I will. Oh, okay, probably I will move to the. We'll move to the question of. Okay, so part A. If we consider the topic about the functions and operation on functions, the basic idea is that to know the domain and the range of given function. Okay. Okay. And then yeah, the second one, okay, obtaining the graph of a certain function from the graph of elementary function. By using translation or dilation. Okay, perhaps translation is the basic one. All right. So, okay. Okay. So the next one, to know that the constructing composite function constructing the composite function from, let's say, two functions. Okay, and writing the domain and probably and the range of the composite function if we are given the information about the composite one. Okay. Okay, I will give you an example for this. Okay, so this is the example. For example, if you are given two function, so let's say fx equals to square root of 1 minus x squared, okay? And gx, let's say, is 1 over x here. Okay? Then, okay, the basic part for this, so you have to know what is the domain and what is the range of g, f and g here. Of course, the domain of f, I will write incomplete. The domain of the function f is the set of number x for which 1 minus x squared is greater than 0, or can solve this equation to obtain that x is in between -1 and 1. Or you can write it as the closed and bounded interval -1, 1. Okay. Yeah, of course, if this is the short answer question, you only need to write either this interval, oops, sorry. Only need to write, let's say, this interval only, or this set. Okay, so that's only the final answer. Okay, so that's the domain. And for the range of f, is, let's say, r of f equals to, okay, so you'll see that here, set of y for which y is equals to 1 minus x squared, where x is in between -1 and 1. Okay, so that's how we find it. Of course, in this case, square root of 1 minus x squared is always non-negative. Okay, so in this case, y should be non-negative. Y is greater than or equal to 0, but y is less than or equal to 1. Okay, so that will be the range of f. All right. Similarly, the domain of G is, as you know that G is 1 over x, so the domain of G should be any non-zero real number. X is non-zero, or you may write it as real number R minus 0. And same applies here, the domain, the range of G is the same. It's a non-zero real number. Now, what happens if we consider the composition of the function here? If you want to know what is the domain, let's say, of, if you consider G composite F, then you have to consider G evaluated f of x. That will be 1 over f of x. And this is 1 over square root of 1 minus x squared. Okay, you may first find the formula of the composite function. And then to consider the domain, G composite f is, you consider the domain G composite f. So in this case, is the set of number x. First, in order to have G composite f, G circle f here, so you have to know, we have to calculate f of x first. So in this case, is the first restriction to the value of x will be x should belong to the domain of f first. Okay, and then f of x belongs to the domain of G. That's it. Okay, and in this case, x belongs to the domain of f. That will be okay. So previously, what is the domain of f? It's interval minus 1, 1. X belongs to close interval minus 1, 1. And then f of x belongs to the domain of G. So in this case, saying that square root of 1 minus x squared is never 0. So if you combine these two conditions, then you will have x is in between minus 1 and 1, or but square root of 1 minus x squared is non-zero. And you'll see that square root of 1 minus x squared is 0 if x equals to minus 1 or x equals to 1. Okay. So the solution of x squared minus 1 equals to 0 is x equals to minus 1 or x equals to 1. So in this case, you have the interval will be minus 1, 1. Okay. Okay, so that's the domain of G composite F. For finding the range, then you have to take a look at the graph of this one. Okay. So you'll see that square root of 1 minus x squared is greater than 0. Okay, so to find the range of G composite F, so you have to note that okay, 0 is okay. So if x belongs to the domain of G composite F, and in this case we just find that this is an open interval minus 1, 1, then okay, calculate this one. Square root of 1 minus x squared is greater than 0. And it's also less than or equal to 1. Okay, so if you consider this, so we will have 1 over square root of 1 minus x squared is greater than or equal to 1. Therefore, the range of G composite F is the set of here, the set of number Y, or you can write it directly, set of number 1 over 1 minus x squared, where x is in between minus 1 and 1. And literally, this one would be the set of number Y for which Y is greater than or equal to 1. And you can write it in interval notation as 1 comma infinity. Okay. Any question or comment so far?
Comments, sir. All
Any
clear.
question? Is clear?
Yes, sir.
Okay. Okay, so that's the about the composite function. Now the idea is that if you want to yeah, that's the composite function. So let us go back to the tutorial problem. Let's say, okay, so there are if you consider, let's say, number 19, you can view this as the problem for a composite function, or about translation or deletion of the graph of the function. It's both concept for this question will be the same. Yeah, it will give you the same answer. For example, let's say if I want to, okay, so if we want to, let's say we will, okay, I will slightly modify the graph. For example, I just restrict the graph, okay, above the interval. What is the interval? -4 until 3 only. Okay, so I mean, suppose that you erase this part. Okay, suppose that you may erase this part. Okay, so in this case, if you want to, okay, so if the graph of the f is given as follows, so then the domain of f, what is the domain of f here? Gulam, what is the domain of f? Gulam, Muhammad Gulam. Yes, or anyone? What is the domain of f in this case?
Based on the function, it's from
Yes.
-4 to 3.
Okay, so the domain of f is the closed interval -4 until 3, right? Okay. And what is the range of f in this case? Okay, range of f is
-1 and 1, sir.
-1 until
1
until
or 2, sir.
until 2. -1 until 2. Good. Okay, so based on this information, actually you may see that, for example, if we consider one, okay, so we will consider A and B. If you consider A there, you may view this function G for part A. So if A So part A, if you see here, G is a composite function of function x minus 2 with f, right? Okay. So in this case, if you want to have the domain of G, so actually G is a composite function of, let's say, f and h, f circle h, where h of x is x minus 2. Okay. Or you just translate the graph to units to the right to obtain the domain. Okay, so that's to approach for this problem. Okay, so let us use the composite function approach. And in this case, the domain of G will be set of number x for which x minus 2. Okay, so since we want to calculate x minus 2, then x minus 2 should be in the domain of f, right? X minus 2 should be in the domain of f. And in this case, that would be x minus 2 in between minus 4 until 3, right? Okay, so in this case, set of number x, okay, just solve the inequality x minus 2 in between minus 4 and 3, get x is in between minus 2 until 5, right? Okay, so you will obtain the interval 2, 5. Okay. How about the range of f? Range of g. So you see that g actually is the same as f, but it's evaluated at another place. So or geometrically, if you just translate to the 2 units to the right, you'll see that the height or the amplitude of the graph of the function f is unchanged, right? So in this case, the range of g will be equal to the range of f, and that will be minus 1, 2. Okay. Up to this point, is it clear? Is it clear?
Yes, sir.
Okay. Any question? Okay, I hope there is no question. So, okay, so if you consider part B, for example, the domain of, okay, so this is completely the, oops. Completely different function. So I will erase it for part B. For part B, g of x equals to fx plus 1. So you'll see that in this case, if you take a look at geometrically, the graph of g is obtained by translating the graph of f1 unit above. Okay, so there is no change in horizontal direction. So in this case, or if you see algebraically here, okay, g of x is f evaluated at x only. So in this case, the domain of g equals to the domain of f. And the domain of f in this case is minus 4, 3. Right. On the other hand, so you will see that g of x is fx plus 1. So in this case, you have to find any possible value of fx plus 1 where x is in the domain of g or in the domain of f. This is the same. In this case, since since the range of f is minus 1, 2, then it's at by 1 unit. Okay, so the range of g will be 0 until 3. Okay, so that's the type of part equation for function and the operation on functions. Okay, so I hope that you can, yeah, understand. You understand how to deal with the operation on function and composite function. Okay, any question or comment? Okay, so I will stop now. Okay, so I will give you the. Okay, so let us continue to the next chapter about the limit. Okay, for the limit, and the typical example will be to calculate the limit of the function by using the using the graph function. Okay, so I will give you let's say 3 or 5 minutes to work reworking the following question. I think that we have discussed it in a tutorial problem, but okay, so as a practice, let us work on this problem. Okay, I will give you first to answer it, and then I will discuss this. Okay, so in this case, we have the graph of the function f, and then you should answer the question about the limit here. Or okay, I will give an additional question. For example, the question, okay, to calculate what is the value of f1. Let's see here. What is the value of f2? For example. Okay, and then also this limit. Okay, first let us think about this problem. Okay, so the idea is simple. You are given the graph of the function, and then you have to know what is the limit, either left-hand limit or the right-hand limit of the given number here. Okay, I will give you a moment, and then I will discuss it. All right. Okay. So thank you for reminder. I will open the attendance review for midterm. Okay. Thank you. Okay. So let us go back to the tutorial problem here. So if you are given the graph of the function like this, okay, first, if the question is to find the limit as x tends to 0 of fx, then you have to take a look at the value of f around x equals to 0 there. Okay, so you have to consider this part. Okay, and you'll see that as x approaching to 0, then f of x is approaching to 0 from the graph. Okay, and here is quite easy because the function is continuous at 0. Actually, if this is the case, then you may take the limit, the value of the limit will be the value of the function itself. Okay, so now let us consider part B. In part B, the question is to find the limit as x tends to 1 of f of x. And here, if the function is not continuous at 1, unfortunately, but you may take a look at the behavior of the function around x equals to 1. So you'll see that as x is approaching 1, the value of fx is approaching 2. So that's why the limit here is equal to 2. Okay. And okay, so that's part B. So part C and D, okay, because they are related. Here is the left-hand limit and the right-hand limit. And once again, the function f is not continuous. Okay. So in this case, if you want to find the solution, okay, let's say for part C, the right-hand limit, then you have to take a look at the graph of f, but only consider the part right to x equals to 2. So you for part C, you only focus on this part. Okay, and you see that as x is approaching 2, okay, then the value of fx is approaching 0. So that's why the right-hand limit will be 0. Okay, and if you consider the left-hand limit, if you consider the left-hand limit, then you only focus on the part to the left of 2. So you only consider this part. And you'll see that as x is approaching 2 from the left, and you know that the limit is, you know that the value of fx is approaching 1. So that's why it's approaching 1. So that's why the left-hand limit is 1. Okay, so the question E is actually the combination of C and D, because you'll see that the right-hand limit of f at 2 in part C is 0. The left-hand limit of f at 2, once again, is 1. And they are different. They are not the same. So the conclusion for part E, the limit of f at 2 does not exist, because the left-hand limit and the right-hand limit are not equal. Okay, and of course, for part F, if you continue this way, because it's a horizontal asymptote, you know that the limit at infinity equals to 1. Okay, so that's the answer. I have to add several comments. Sometimes, for example, if you want to revisit the part B there, although the limit is 2, but you'll see that from this information, the value of f of 1 is equals to 3 there. Okay. And in this case, okay, so you'll see that the limit here is the behavior of the function close to 1, but we can omit the value f1 itself. Okay. And in this case, f1 equals to 3. You may see the dots here. Okay, the dot here denotes that the value of f1 is 3. Similarly, if you consider part E, although the limit at 2 does not exist, then you know that the value of f at 2 is here, is the dot here. Okay, and simply f2 equals to f2 equals to 1. Okay, so I have to remind you that you have to be careful with the difference between the value of the function and the limit from the graph of the function. It can be quite similar here. Of course, in case of x equals to 1 and x equals to 2, they are totally different. Okay, especially so if you consider the case where the function is not continuous at that point, then the limit and the value of the function is obviously not the same, or are not the same. Okay. But you have to distinguish which one is the value of the limit, which one is the value of the function. Okay, any question or comment up to this point? Any question or comment?
No, sir.
Okay, I hope it's clear. All right, now, okay, so let us, yeah, this is about the, okay, I will summarize about the limits. Okay, so the topic is finding the value of the limits, yeah, and the value of the function from the graph of the function. Yeah, so that will be the goal for short answer question. Okay. Any question or comment so far? Okay, I will continue. Okay, so I will first I will I forgot to unmute myself. Okay, so now for chapter 2 about the derivatives, the usual concept will be to see the meaning of the graph of the meaning of the derivatives. Okay, as you done before, the meaning of the derivative is some function is the slope or is the gradient of the tangent line to the graph of the function at a given point. Okay, so for example, you have to understand the concept of 1a here. Okay, so you'll see that the gradient of the tangent line to the graph of the function f, the point c comma fc is the limit of h tends to 0 of fc plus h minus fc divided by h. And if the limit does exist, then this is the value of the derivative. Okay, so if you are given, let's say the function f, y f of x, then if you want to know the gradient of the tangent line to the curve y equals to f of x at the point c comma fc, then okay, then the graph will be then the gradient of the tangent line is f prime of c. Okay, so that's the basic part. Okay, of course you have to know how to calculate the derivative by using the definition. Okay, for example, in number 2 or number 3 or in number 4 as well. Okay, and from the definition, how do you find the value of f prime of c, and then use this information to construct the equation of the tangent line at the given point. Okay, so I will consider an example for this. Okay, this is the derivatives. Okay, I will write the theme. The main topic for this is to find the equation of the tangent line to the curve y equals to f of x at the point, let's say c comma fc. Okay, so the basic idea is that the gradient of the tangent line is f prime of c. Okay, the gradient is f prime of c. Then the equation of the tangent line will be y equals to f prime of c multiplied by x minus c plus f of c. Okay, so as an example, if let's say the function here is not given by the formula, but let's say the value of c is given, let's say c equals to 3, and then f3 is given, let's say equals to 7, and f prime 3 equals to -2, for example. Then simply by using this formula, then you have to know that the equation of the tangent line is y equals to -2. Just substitute the f prime of 3, c equals to 3 there, and fc as well. Then the tangent line, okay, I will write incomplete. Then the tangent line to the curve y equals to f of x at the point 3 comma f3. So c equals to 3, so 3 comma f3, or you just replace f3 by 7. 3 comma 7 is y equals to f prime of 3 is -2. Okay, I will write in detail. F prime of 3 x minus 3 plus f3. F prime of 3 is -2 multiplied by x minus 3 plus 7. So you see that I have -2x plus 6 plus 7 is 13. I have -2x plus 13. Okay, so that's the equation of the tangent line to the curve y equals to f of x at the point 3 comma f3 or 3 comma 7. All right. Okay. So of course, okay, so this is yeah, it's a concept question. So you have to know how to construct it. Maybe there is a reverse question or the converse question. If you are given the tangent line, then you have to know, if you are given the equation of the tangent line, then you have to know what is the value of the function at that point, at the tangent point, and what is its derivative. Okay. Okay. Any question or comment up to this point?
No, sir.
Okay. If it's clear, then let us continue. Okay. So far, we have considered the question about the function and its graph, so operation on function, composite function, as well as the translation, horizontal translation and vertical translation. It's a domain and its range as well. And then limits, finding the limits and the value of the function from the graph of the function as well. And then the derivatives, the meaning of the derivatives. Okay. So the next one, probably if you, okay, if I go back to the, where is the tutorial? Okay, so the next question maybe about the, okay, about, for example, if you consider number 13 here, if you are given the value of the function, the value of its derivative at the same point, and also another function, the value of another function at the same point, and as well as its derivative, for example. Okay, so you have to know how to calculate the operation of these two functions. Let's say the sum, it's a subtraction, the product, and it's a ratio as well, by using the rules for finding the derivative. For example, in number 13 here, here just simply, for example, 13a, if you want to know what is the derivative of f plus g at 2, is simply just f prime of 2 plus g prime of 2. Similarly, f minus g prime of 2 is just f prime of 2 minus g prime of 2. Okay, so that's quite easy. For C and D, you have to be careful. You have to apply the product rule and also the quotient rule to find its derivative, because the derivative of f, the derivative of the product of f and g is not the same as the derivative of f multiplied by the derivative of g. You have to write, for example, the derivative of f multiplied by g is f prime 2 multiplied by g of 2 plus f2 multiplied by g prime of 2. Okay, so that's the formula. Of course, you have to know what is the appropriate formula of the ratio or the equation rule here. Okay. Okay. An alternative for question will be another rule. For example, you have to combine this with the derivative of trigonometric function, for example, or the question. Okay, where is the question related to the chain rule, for example? The typical example problem will be about number 24. So if you are given the value of f, the value of f prime, the value of g and g prime there, okay, you have to know how to calculate the derivative of, let's say, g composite with f. Okay, so you have to know, or you have to recall the formula for the chain rule here. For example, the derivative of G circle F will be G prime evaluate F1 multiplied by F prime of 1. Okay. And in this case, G prime of F1. So you have to calculate what is the value of F1 there. Okay. From the table, F1 is -1. So we have G prime at -1 multiplied by F prime 1. F prime 1 is from the table is 2. And G prime -1 will be 3. So 3 multiplied by 2. So this is also a possible question. From the data about the value of the function and the value of its derivative, just find the value of the derivative of composite function. Okay, so it's also a typical question. All right. Any question or comment so far? Okay. If this is not the case, okay, so let us continue to. Oops. This one. Okay, so for chapter 3 about the okay, so the typical question will be okay. For example, number 2, if you are given the graph of the function, then you have to know what is the maximum, the minimum value given. So here, the graph of the function is not given. The value is not, the formula is not given, but the graph is given. Then you have to know what is the, let's say, the boundary point, the stationary point, or the singular point, as well as the what is the minimum values and the maximum values as well. Okay, so that's pretty basic. And okay, okay, so another one will be the question of number 8, for example. Okay, so suppose that the function is differentiable everywhere, and the graph of the function, the graph of its derivative is given. Okay, so you have to know what is the relation between the sign of the first derivative, the sign of f prime, with the monotonicity of f. Okay, so you'll see that in the picture there. Okay, you'll see that the graph of f prime here, from the graph of f prime, so f prime is negative. F prime is negative. F prime of x is negative for on the interval -1, -1, 0. So you'll see that since f prime x is negative on the interval -1, 0, then the conclusion will be f is decreasing on the interval -1, 0. Of course, for other part of the function, for other part of f prime, so for example, f prime is positive on the interval -∞, -1, then f is increasing on -∞, -1. Okay, so in this region, okay, the same applies if, okay, so I will use a different color there. So in this case, f prime is positive, and also in this case, f prime is also positive as well. So you'll see that f prime is positive on the interval of 0, ∞ as well. So f is increasing on that interval. Okay, so right. So you have the monotonicity. On the other hand, if the question is about the concavity, so you have to know the location where the function is okay. So here you have to decide the concavity from the information about f prime, and recall that if f prime is increasing, then the graph is concave up. The graph of f is concave up. On the other hand, if f prime is decreasing, then the graph of f is concave down. Okay, so you'll see that from this picture, from this to this one, f prime is decreasing. Okay, and also from this one to this one, f prime is decreasing. Okay, so in this case, you'll see that on the interval minus infinity until minus 3 over 5, the function is concave down. Okay, so f is concave down on the interval minus infinity, minus 3 over 5. Okay. Similarly, f is also concave down on the interval, let's say 4 over 5 until 2. F is concave down on minus infinity until 3 over 5, minus 3 over 5, and from 4 over 5 until 2. Okay, it's also concave down. Of course, the complement, okay, for example, from minus 3 over 5 until 4 over 5, the f prime is increasing, so f is concave up. Okay. Similarly, from 2 until infinity, the function is the f prime is again increasing, so f is concave up as well. Okay. Okay, so that's the idea. Of course, another information about the local extreme value, okay, or the inflection point is the point where there is a change of concavity. Is also a possible question from the picture, as well as a problem, let's say, like number 11, 12. Okay, although the question is about the sketching the graph, maybe the similar question about the graph of the function is given, but we do not have the formula for the function, but we have the property of the value of the function, the value of its derivative, its sign of the derivative. Then we can, then the question is whether we have to compare the value of the function at a certain point, whether it's greater or equal or less than or equal, for example. Okay, so that's the about the the rough summary for part A. Okay, so any question or comment?
Yes, sir. I have a question about number 8 just now. If that's okay.
Number eight in here.
I think it was number 8. Yeah,
Yes.
yeah, that one. The one that looks like a W. So you said from negative infinity until negative 3 over 5.
Yes.
It's concave down or up?
Concave down, because f prime is decreasing.
Or f prime is decreasing, isn't it? Increasing because it's going from negative like slope to a 0 slope.
Okay, so I have to make sure from the graph, the value of f prime is decreasing because the value to the left is above the value to the right, right? Okay, f prime is decreasing. Is it clear?
Yeah, but like f
Yeah,
prime
I
is
have to
the
measure
slope of the
first.
graph, right?
F prime is decreasing or not first?
I don't think it's decreasing. If anything,
Huh?
it's increasing.
Okay, so I
For
will ask
f
you the
prime?
question. F prime of -1 is?
Oh, sorry, never mind. Yeah, I'm very sorry. So this is the graph for F prime, yeah.
Yes, yes.
Yeah. Sorry. I thought it was the
Okay.
graph for F. Yeah, I'm very sorry. Yeah, never mind that.
Okay. Okay, F prime here.
Thank
Okay.
you.
Any
Yeah.
other question?
No.
Okay. So, okay. So the next one. Okay. I will. For part B, is a short essay. Okay. Usually, you can solve this in 3 or maximum 4 steps. Yeah. Of course, it's major steps, but for each step, you have to write the detailed argument or the detailed reason to obtain the conclusion there. Okay. So in that case, okay, for example, I will give you a highlight for this. For example, solving an inequality, for example. Okay. And the typical question will be the question from, okay, I will continue. Let's say, okay, so for example, if you consider number 4 or of N5 there, okay, although several question can be too long for short answer question, sorry, can be too long for the essay question, then the standard one, for example, 5A or 5B, okay, the standard one is 5A or 5B. In that case, okay, so for example, the inequality for absolute value, then you start with the meaning of the absolute value. Okay, so you have to solve the inequality. For example, the probably the appropriate question will be 5A there. For example, 5A is the inequality, the solution to the inequality absolute value of 2x minus 3 is less than 1. Okay, so the basic idea will be to write 2x minus 3 is in between minus 1 and 1, and then simplify it. 2x minus 3 is between minus 1 and 1, so 2x is in between 2 until 4, so x is in between 1 until 2. Okay, okay, so the difference between part B and part C here, for example. Okay, the question is solve the inequality. It's the absolute value of x minus 3 is less than 1 here. Okay, so in this case, you have to write your answer in detail, unlike the short answer question. So in this case, okay, to do that, okay, start from the question first. So just rewrite absolute value of 2x minus 3 is less than 1. And okay, you have to solve it, then you have to use the equivalence sign, and then write the meaning of 2x minus 3. It's absolute value of 2x minus 3 is less than 1 by considering the meaning of absolute value as the distance at the number 2x minus 3 to 0. So here the distance from 2x minus 3 and to 0 is less than 1. So the meaning is that 2x minus 3 should be in between minus 1 and 1. Okay, and in that case, okay, 2x is in between 2 until 4. That case, x is in between 1 until 2. Okay, so the common mistake is that usually the answer stops from this point. Okay, but yeah, your grade will not be full if you stop up to this point. So in that case, you have to write that the solution. Okay, so you have to write the conclusion to the problem. So the solution to the inequality is a set of number x for which x is in between 1 and 2. And in this case, we have, you may write it as the open interval. Okay, so you, okay, I have to remind you that you have to write it in full solution like this. Okay, do not skip any steps. Otherwise, your grade will be deducted from the full point. Okay. Okay. So of course, the other possibilities are, okay, where's the are yeah, another point. Maybe part C can be slightly longer, or part D. Okay. But the idea is almost the same. Just write the definition of absolute value and then find the solution there. Or you may consider the part E there. The idea is to take the square of the absolute value sign and then simplify the solution. Okay. Okay, so that about the solving the inequalities. Okay, any question or comments so far? Okay, so if there is no question, so about the second part about the limits and continuity, I will only give you the highlight of these topics, namely the important concept here is to verifying the continuity of a given function at a certain point. The typical example will be if you are given the function of f of x as rule 1, okay, and rule 2. For example, the rule 1 applies for x is less than c, and the rule 2 is x is greater than c. Okay, and then the question is to check or to verify the continuity of the function at x equals to c. Okay? And in that case, what should you do? So you have to check the limit x tends to c from the left of f of x. Okay, what is the result? Of course, you have to use the rule 1 there. Limit x tends to c from the left of rule 1. Then what is the answer? And then the limit x tends to c to the right of f of x. Then let's say if the left hand limit is a, the right hand limit is b. So you have to make sure that a equals to b. Okay? Make sure that a equals to b, and then if x equals to b, then the limit itself exists. If a equals to b and does not exist, if a is not equal to b. Okay, and then after suppose that a equals to b, then you have the value of the limit of f there. Then calculate fc, and then check whether fc equals to limit x tends to c of f of x. Okay, so that's the idea. Okay, so you have to do these steps carefully. Okay, so you have to write all of this, then compare. So start from the left hand or the right hand limit. Okay, you have to obtain the value, and then if the both values are the same, then you have to consider the limit, and then the limit should be the same with the value of the function. And you conclude that the function is continuous. Okay, so that's the basic steps. All right. Okay, so now if we consider the topic for derivatives, there are several possible values, possible option, namely the chain rule. Okay, so you have to know how to calculate the derivative of composite function once again. Implicit differentiation is important, especially if you are given the graph of the function in terms of an equation. So you have to know what is the value of y prime, okay, by implicit differentiation. Okay, and then just use the value of f prime or y prime there to calculate the gradient of the tangent line. Once you have the gradient of the tangent line and the tangent point, you may obtain the equation of the tangent line. And then the concept of related traits is very important. Okay, related traits, it appears in many problems. Okay, and differential and approximation is important. The typical example for differential and approximation is that if you are given, let's say, the function here, okay, then you have to know what is the differential. Okay, for example, if I have y equals to f of x, then differential is differential of y dy equals to f prime of x dx. So the basic part will be if you are given the function, then you have to know how to calculate the differential. The typical mistake will be the differential is only the derivatives, but you have to multiply it by dx. And this is important, especially if you want to approximate the value of delta y. Okay, so if you want to, if delta y is fx plus delta x minus f of x, okay, then delta y is approximately dy, and dy is f prime of x dx. And then in practical problem, have to calculate f prime of x and then multiply it by delta x there. Okay, so but of course sometimes the question here, the explicit formulation of f is not given, so you have to know what is the definition of f in the question. For example, in the word problem question, let's say if the question is about the difference between the volume of two sphere of two balls, for example, then you have to recall that the volume of the ball of radius r is pi 4/3 multiplied by pi r to the power 3 r cubed. Then, for example, if the function f or y equals to v of r equals to 4/3 pi r cubed there. So dy here is f prime of r dr. So in this case, you have 4 pi r square dr. For example, if you want to, if let's say r equals to 1 delta r equals to 0.01, let's say, or 0.1, okay, to simplify it. Then if you want to approximate the difference between f evaluated at 1.1 minus f evaluated at 1, so that will be delta v, delta volume. Then okay, probably notation is not consistent here. dv, delta v is approximately by dv, and dv itself should be calculated by this formula. So in this case, you will have 4 pi 1 square multiplied by 1 square, and then delta r is dr equals delta r is 0.1. So in this case, you have 4 pi divided by 10, so that will be 2 pi over 5. Okay. Okay, so the last problem will be in the chapter 3. Application of derivatives is about the practical problem. Okay, so from the list of these topics here, you may guess that if part C is a long essay equation, you may guess that should be about the mathematical modeling. And in that case, the possible choice for this mathematical modeling is about the related rates and practical problem. So it's better for you to review these two topics, especially in terms of word problems. For example, if I go back to the tutorial in chapter 2, for related traits, it's better to review the question number 34 until 39 there, especially the longer question like 36, 37, or 38, or 39 as well. Okay, so that's the typical one. And for the practical problems, yeah, it's better to consider the question, let's say from number 14 until number 20, especially the longer problem like number 20. So the basic idea is that you have to construct the problem, okay? Oh, sorry, construct the mathematical equation. Okay, and then using the concept of derivatives, okay, and then okay, so solving the equation in terms of the derivatives or in a related rates, and then the conclusion. Yeah, so usually the question for part C consists of 3 sub questions. The first question should be the easier one, to construct the model, and then to derive the related derivatives, and then solve the question for the last. Okay, I think that's all for today. I will save these notes and then send it to you, and then you have to wait the recording. Okay, good luck for the exam on Saturday. I will tell you the detail about the schedule. Okay, thank you for your attention. We'll see again on the exam. Good luck. Have a nice day. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
sir. Good morning.
Thank you,
Good morning.
sir.
Good morning.